Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, gracing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? Nice.
Nice.
Let's get the YouTube going. What's up, Ace? Good to see you. Oh, let me start the Discord stream. Let me get this running too.
Why is everyone?
One sec. Start. I'm kind of fighting a little bit of a cold, but still here. Luckily, I don't have to teach anybody in person today. It's a lot of online teaching. Raven Violet, what's up? What is going on? There we go. There's music. What's up? The Darsh, good to see you, dude. Yeah. Yeah, you can try. I'll probably do them at some point this week. I did them. I did give out the bond coins for this week. Did you redeem any last week? I just gave them out earlier today. I think only lads had redemptions today. Or this week. Boom, boom. Is it somebody's birthday today? Is it Ash's birthday? Dark and Ash are just going through it on the chat today. Okay, cool. Oh, no, you know you can redeem bond coins whenever. Like, you can always come back to the channel and and do it. E Raven says I always get lag. Well, you can always join our Discord. There's no lag on Discord. If you'd like to join the stream on Discord, that's the Discord link. And then there's a stage channel you can watch. Yeah, I guess it is lagging, but give me a second. I wonder where that is. My PC updating something? No, it should be fine. Oh, you know what it probably is? There's a new season of the finals right now. One sec. Let me exit Steam. A says, wait, how? How what? Oh, how can you do it? Yeah, watch, it's very easy. Sorry, let me... Yeah, for instance, if you go to... let's say you go to, Twitch. I don't know. Let's say we go to Penn Center's stream. What's up, Shantrix? I appreciate you commenting on our TikTok stuff. Oh, how can you do it? Yeah, watch. Sorry. If you go to anybody's Twitch channel like this, and you click chat right here, you then get access to the to all the channel point stuff. So you can go ahead and just buy things here. Yeah. So yeah, I don't have to be streaming for you to redeem bond coins. You can do it even when the stream's offline. Just I won't get to it till Sunday. What's up, Ayush? Let's see is it lagging on Discord? It's probably fine on Discord, right? Alright, guys. Hope it is. Oh, and we are streaming on YouTube. That's working. Wow, W. Love that. So if I redeem it today, do I have to wait until Sunday to get it? I mean, technically yes, but I'll probably make an exception since it's the last week. I just do the Sunday things because for my own, like, sanity, I can't be constantly checking the Discord. So I have one day where I check all the stuff and I do all the stuff for people once a week. Otherwise, it becomes a little bit too much. What's up, Recky? Recky Rec. That's cool, man. Anyways, yeah, it is final exams week. So some of you guys may be already on winter vacation. Congrats if you are. But some people I know have final exams this week, which I've been teaching a lot recently. I did not give out the good grades yet. No, I did. I'll get to the good grades this week. I was kind of sick yesterday, so I kind of took a break from things, but I will get to it. A says, our final exams are on January. Oh. Okay, cool. How do I redeem watching stream points? So at the bottom there in the Twitch, there's you should see like a channel points counter. And then you can go there and you can buy bond coins and stuff. Yeah, we are dropping a fuck ton of frames. What the fuck's going on here? No, it says okay now. Yeah, I think it was just something was updating land. Anyways, let's see. News for today. Oh, we are gonna have a Golden Hour AMA podcast guest on Friday. Super excited about that. He's a big college counselor. He helps tons of people with getting into college. So if you've ever wanted to ask questions about from a professional college admissions person, he's gonna be with us on Friday. His name is Perry. He's a very cool guy. So I'll make the announcement about that later today. And just like always, submit questions to ask him during the stream. And if you get the best question, or he thinks your question's the best, you win $20. So, that'll be fun. Adar says, I have 2 final exams tomorrow, chem and computer science. Okay, cool. Good luck. Yeah, good luck with all your finals, guys. So yeah, this will be the last week of streaming for 2024. Because then I gotta go do Christmas things. I gotta go to Chicago. It's gonna be so cold. How many V-Bucks can you redeem with Tier 1 Prestige? $25? I don't know. See, it used to be that, like, Tier 2 was they keep raising the prices on the V-Bucks. It used to be $20. Now it's like 23 technically for the 2800 V-Bucks, but I just give it to people anyways. I'm in Canada. Yeah, it's way colder there. I bet it is. Yeah. I bet it's fucking freezing. I don't like the cold. I'm not a cold person. Anyways, looks like we got a lot of good questions today. Where's Critical? Does Critical want help with this stuff? I felt bad not being able to answer your criticals. You're so hyped for Friday? Yeah. Friday will be a lot of fun. Yeah. You guys will love the guest. He's a really cool guy. I met him through like some business work mixer thing, so he's pretty cool. And then when will I start streaming after 2024? Probably in the new year. We do it like the first week of the New Year's. So, which I think maybe, let me see what it is. I'll make an announcement about it. I always do. But if we go to like, let's go to the calendar. Yeah, so I need to add in we'll have the AMA podcast guest on Friday. I'll add that in. I just got confirmation from him today. But then, yeah, I'll take all these out. We're not going to stream this week. And then, so probably January 6th, I think, is when we'll start again. Yeah. It's just because, like, it's the winter. You guys should take a break. I need a break, too. It's a good time for me to, like, reanalyze, like, what happened this year and what to do next year. Do you like maple syrup? I fucking love maple syrup. Hell yeah. Half day for school, AMA podcast, winter break. Yeah, dope. That's dope, man. I'm glad to be a part of your awesome Friday. That makes me feel good. Okay. Let's see. Anything else? Oh, I did put out a TikTok. How's that TikTok doing? One second. Let me just check. I haven't even checked any of my metrics today. Nice. Okay, cool. 11K, 28K. A little low. But so for anybody who's wondering about posting things on TikTok and YouTube, this is like kind of the end of the good times to post things, especially educational wise, because most people are done with school. So even though we have like videos out here, they're just factorized. I gotta go through all these comments. Everyone's trashing my completing the square. I'm like, bro, but you need to complete the square. Oh, you did on your channel? Oh, sick. Yeah, I think I'm following you on YouTube, right? If I go to Shantrix, I should be following you. Shantrix. Oh, nice. Okay, here. Oh yeah, here's your. Oh, nice. Sick, dude. Oh, Minuet. I love this, dude. I love that you're posting, like, this is a good thing for accountability, dude. Like, even if, like, you know, 2 people watch it, the fact that you're even doing it is better than 99% of people. Oh, Minuet and G minor. This is a fun one. Oh, sorry, let me take the lo-fi music off. Nice, dude. Yeah, post this in the music thing. I'll make sure you get credit for it. This is cool, dude. I know this isn't the best ever, but I need to post today, so yes. Okay, good. Yes. I agree with so many of these things, Shantrix. Yeah, the important thing is to be consistent with putting things out. You know, it doesn't matter if it's not the best or, you know, I say don't keep things in what we call like perfection cages. A lot of times people don't want to release things because they say, oh, it's not good enough yet. And my whole philosophy behind that is that nothing will ever be good enough yet. Nothing's ever perfect, but putting something out is better than not putting out anything at all. Is my income on TikTok good? I don't know. They paid me $40 yesterday, so I wouldn't say it's good, but it's definitely above zero. E Raven says, any advice on getting better in math? You know, practice. Hanging out on math streams like this. I don't know. Where'd you find us from, E Raven? Did you find us from TikTok? Why are you wearing so many rings? Oh, I just like rings. I'm a fan of accessories. So, for those that are new and don't know, we have a whole collection of other people on Twitch here who stream free math help, or just they do fun stuff with math on Twitch. So, if you like consuming, you know, media and spending time on Twitch, make sure you go follow those people. They're friends of ours. They're super dope. And that's one way to just get better at math. It's to become, I think, more familiar with it. I think people usually say that they're bad at math because they're afraid, because they don't understand all of it, which is natural. I mean, I don't understand a lot of stuff, but once you become more familiar with things, they seem less scary, and then you're just gonna be naturally more confident and better at just doing things in math. Like, I can't tell you how scared I was every time I saw like sine or cosine. You know, that stuff would just like freak me out. Oh, sick. I searched math on Twitch and joined the Discord, The Elements. Yes, that's our friend Penn Center. Penn Center's awesome. We love Penn Center. Penn Center. Brian, yeah, he's a great guy. We like Penn Center. He's awesome. So, yeah, Penn Center does cool streams. He tends to do sometimes a little bit higher level math. I don't know what, like, math level you're at, E-Raven, but I tend to focus on middle school, high school, like early college. He tends to do late high school, college, even some graduate stuff. So he's my go-to for higher level math. Anytime there's something where I'm like, oh man, this is like set theory, or I don't know, algebraic topology, I'm like, okay, go to Penn Center, because my math tops out at like complex analysis. Wait, Carmel, sorry, you said something earlier. So I'm sorry. I have a question. A philosophy teacher told us that the soul could have seen the last decimal of pi, where the soul is what explains what all our brains are. Doesn't sense. Can you help? Do you think it's possible to talk about the last decimal? No, because it's irrational. It just keeps going on forever. There is no last decimal. Okay, Reki says grade 11 math. Great. So yeah, then Penn Center probably goes over some stuff. You're probably doing calculus or whatnot. And then I can definitely help you. I work a lot with high school kids. Tons of high school. Okay. Oh, that's fine. It says like I should be. Yeah, that word. Yeah. We're all here for the high school fundamentals. And that's another thing. If you just watch the stream while we go over homework questions, I'll explain like the fundamental steps. And if any of those things don't make sense, let me know, and I can make sure they do. You have to have the building blocks set if you have to have a strong foundation if it's gonna build up. Yeah. But yeah, what's cool? So, Caramel, you bring up a cool thing. I like saying that pi is a beautiful example of why I think we live in a simulation. Because, what is it? Oh, go way all off. And that's my wrong calculator. Okay. If you have, for instance, a circle, right? Which is one of the most natural shapes in nature, right? Wait, where's my circle? Circle, right? The ratio, right, between the diameter of this thing, right, the diameter, and the circumference. Let's say the circumference going on. Is this, right? Pi times d is equal to c. So the ratio of the circumference to the diameter is equal to pi. And pi is an irrational number. Irrational means like it does not ever end. Like the decimals just keep going and there's no pattern. Some things have nice patterns, like 1/9, I think it's technically, well, no, it's not irrational, but it's a fraction. But that looks like this. It's just 0.1111. It's just a bunch of ones repeating with each other. So the last decimal, you know what it's going to be. Or some stuff has like patterns. It's like 137, 137, 137, or whatever. But pi just like goes on forever. Like I know a couple. 1415926. That's all I know. Some people can go like hundreds and hundreds of digits. Shantrick says he was doing something like complex function or something, and I didn't know, so I said that looks complex, and he thought it was a pun. Yeah. Yeah, he does a lot of complex stuff. Complex analysis. Yeah, you're right. Even 1/7 doesn't have, you're totally right. But it has a pattern though, right? So even though it doesn't have a last digit, if I want to know, like, for instance, what the whatever digit is, I guess I can figure it out. Like, right, what is 1/7? Oh, does 1/7 not have a pattern? That doesn't look like it has a pattern. Oh, it does. Oh, it's okay, I see, because it's rounding this 8. So it's 1428 repeating. Is that what it is? Okay, is it this? Is that what it is? Okay, cool. Yes. Okay. Yeah, sorry, but just yeah. So it's it's all of this, yeah. So this is I think this is technically called rational though, right? Because you can still write it as a fraction. Pi you can't even write as a fraction. You can get close, right? Pi is, I think, close to 22/7. Yeah, I always remember rational ratio, right? But like if I do 22/7, 3.14, yeah, I mean that's like the closest I think you can get. That's like, yeah, pi's irrational, e's irrational. Yeah, so I mean, my basic, or my take-home message from this is that even in the real world here, that we've like come up with number systems and math and whatnot, even the most basic of concepts, like what it takes to go around a circle and what it takes to go directly across it, can't be explained by a rational number. Like our system of math can't explain it. It just like it goes off forever. To me, it seems like it's a rounding error, or like the refresh rate of the universe. So I don't know. That to me kind of blows my mind, that like something so simple as the circumference to the diameter doesn't have a well-established number. So we must be living in a simulation. Pi plus e is obviously, yeah, exactly, ratio, yes. Jeff says the other explanation is that our base 10 system is flawed. That's true, but it works so well for so many other things, right? So And I think there is some natural, I don't know, the base 10 seems to be pretty cool, right? I mean, yeah. Have they tried to express pi in other base whatever systems? I'm sure they have. I mean, I guess if you had a base pi system, it would be 1. I mean, that's a nice thing. But then everything else would suck to explain. Right. Nature has E, pi, and the golden ratio. Yeah, it's very cool. Hey, you want some... I swear, we'll do math questions in a second. I'll just check these out. These are cool. Golden ratio in nature. Yeah, stuff like plants. Plants love the golden ratio. Yeah, this is like some really cool stuff. Chameleon tails. Look at this. Like the tail of a chameleon. Has a spiral shape that looks like the golden ratio. Oh, seashells as well. Yeah. Fern fiddleheads. Ocean waves. Wow. Flower buds. Snail shells. Yeah, these are dope, dude. What do we call these? The fractal vegetables, Romanesco broccoli. These are so cool. You can eat these. Whirlpools, comfrey flowers. Yeah, there's a bunch of really cool things in nature that come about with that. Oh, where'd my thing go? One sec. There it is. Yeah. Anyways, cool. All right. I think, yeah, good discussions, everything here. Let's do some homework questions. You guys feel free to, like, in the chat, type things we're doing. And let's help you guys out with finals coming up. All right. Welcome, everyone, Office Hours. My name is Dr. Cole with Actual Education. Student help you with math homework, science homework.
Nice.
All that fun stuff. Yes. It's Monday. I have 4 other students later today I have to teach. Oh, nice. I love all these questions. We have so many questions today. Great. Okay, let's do them. All right, first up, I got a Darsh. Darsh, what's up? Let's see if he's in here. It's in the chat somewhere. What's up? Okay, cool. All right. Common denominator. Yes. So again, if you're watching and you want to learn some math, high school math fundamentals, there is going to be a lot in here. So the first fundamental here is that in order for us to combine fractions, they need to have the same denominator. So for instance, if you're trying to do like a quarter plus a third, you can't just add these right now. Right? It doesn't really work. So what you end up doing is multiplying this one by 3 over 3 and then this one by 4 over 4 so that they both have a denominator that's equal to 12. Okay. This one is easy. Okay. Yeah. So, well, exactly, Shantrix. Yes. So what I see here is I see 3 different denominators. Okay. But what I want to, in order to be smart here to kind of save some time, is that I can notice that this denominator right here is actually a combination of these denominators. Okay. So in this case, because I have something squared minus something else squared, that goes by this thing. This is called a difference of squares. A squared minus b squared is equal to a minus b times a plus b. So instead of saying d squared minus 4, I can say this is d minus 2 times d plus 2. Do we see that? Does that make sense to people? If anything doesn't make sense, or you're like, wait, what's that magic that you just like pulled out of your hat? Let me know. I'll go through it. I want to make sure you guys understand things. But okay, yeah. All right, sweet. So once we've turned this into this, now I notice that okay, the thing I want everything, the denominator I want is really this. Which now we're going to look at each one of these things and see which part of the denominator it's missing. So this one right here is missing a d minus 2. So I'm going to multiply the top by d minus 2 in parentheses and the bottom by d minus 2. This one here is missing a d plus 2. So we're going to multiply this by d plus 2. We're going to multiply this by d plus 2. Right? And now let's like distribute stuff and see what we get. So this gets us 2d minus 4 And then this is plus 8D plus 16 is equal to 14. And then all of these things on both sides are over D minus 2, D plus 2. This is also over D minus 2, D plus 2. Okay, so there's a little bit of a trickiness here. Because these things both have this on the top, on the bottom, I could technically just kind of get rid of these, right? Or like, they go away. Because I could just multiply the top by D minus 2, D plus 2, and multiply the top of this one by D minus 2, D plus 2. But we're going to have to check our answers later, because I don't think D is allowed to equal 2, negative 2. Or 2 or negative 2. I don't think those are allowed solutions, because if we tried to plug those back in, we would end up dividing by 0, and that's bad. Don't want to divide by 0. Divide by 0 is real bad. But for now, I'm just going to focus on this equals this. Yeah, those would be excluded values, but they may not even come up, honestly. So let's see. So I have 2D minus 4. So let's combine things, right? So minus 4 and plus 16 is going to be plus 12. And then 2D and 8D is going to be 10. So I have 10D plus 12 is equal to 14. Okay. So then I'm going to subtract 12. 10D is equal to... Oh, negative 12. Did I fuck something up here? Sorry, let me see. Minus 4 plus 16 is positive 12, right? Minus 12, minus 12. Okay, good. No, that's fine. All right, and then we just divide by D. Or divide by 10, sorry. Oh, yeah. Thanks, Shantrix. Shantrix, you're good. So D is equal to 1/5. Nice. Nice thing about D being equal to 1/5 is it's not any of our, like, not allowed values, right? So, yeah. Okay, cool. So, yeah. So then your final answer is 1/5, and you're done. Yes, we could plug back in and double check. I just don't want to. My head hurts. But yes, very, very, very a good. It's just plugging back in would actually kind of really suck on this one, though, right? Because look at all these like fractions on the bottom. What? Oh, you forgot to multiply 3 on the denominator. Oh, that's okay. But where were you multiplying by 3? I don't think I wrote down a single 3 here. Yeah. Okay. All good. Cool. Nice. Yes, if you're watching in the chat and you want to ask a question, please do. We have a whole... In the Discord, there's a channel here called Help Screenshots. And so this is where students submit things that they're doing, and then we go through them on the stream. Yeah. All right. Let's see. Next up... Oh, Shantrix, you got a tough one here, right? Is this a what is it, a math challenge question? I see 24, which makes me think that it's one of the last ones. This is on the Pascal. Yeah, it says on the Pascal. Okay, cool. All right, I'll give myself 10 minutes to try to answer it, and then I'm gonna look at the solutions. Because I want to make sure I have time for all the other students who have questions today. Okay. Let's see. CD equals CE equals 30. Okay. Okay, so this is 30. Cool. I like this. I like this so far. Not too bad. 30. 30. And F is the midpoint of CE. Okay, cool. That tells me this is 15. This is 15. 2 quarter circles are drawn, one with a center at C, passing through D and E. Okay, so that's this one. So that tells me that this is a radius, right? This is a radius of 30, I believe, yeah. CD and D and DE. Oh, through D and E, okay. And the other has a center at F, passing through E. Okay, cool. So then this has a radius of 15. Right, this is also 15. Let X be the area of the region that is inside angle GCDF and outside the larger quarter circle. And let y be the area that it's... Okay. Let d be the positive d. Let d be the positive difference between x and y. Okay. So they want to know the difference between... And then... Oh, to the nearest integer. Oh, that's kind of cool. So then they want to know this region, right? Minus... this region, I believe. Yeah? And are we allowed to use calculators, Shantrix, by the way? Sorry. Or does this all have to be kind of done in your head? Oh, you are allowed to use calculators. Okay, cool. All right. Well, not bad. Mm-hmm. Well, I think to get x, I know x has to be the area of this rectangle minus the area of the triangle minus the area of this arc, right? So x is going to be equal to the area of the triangle. So that's 1/2 base times... Oh, then I got to know what this height is. Oops. Oopsies. Oh, interesting. Yeah, Pythagorean theorem. Yeah, I know I can do it. But then I also need to know this. Oh, yeah. Thank you, Jeff. Yeah, because I know this is 30. Duh. Yeah, okay, so 15 squared plus, I don't know, let's call that z. I'm going to call this z, whatever. Z squared is equal to 30 squared. I want to get, like, this distance. Is it a special triangle? Wait, which special triangle is it? Oh, is it the... one second. Wait, which triangle do you think it is? Sorry, 530 divided by 5. That's something 3 and 6. Oh, it's 1, 2 squared of 3. Oh, that's very cool. Oh, Jeff brings up a great thing. Yeah. So, oh, you know what? This actually helps us solve some other things, which is nice. So, one of the special triangles that you learn, which is the 30, 60, 90. Okay. Let's say this is 30. And let's say this is 60. And then this is 90. What you learn is that 1, 2 squared of 3 is, yeah, one of the triangles. I like also doing it as just like 1, and then this is 1/2, and then this is square root of 3 over 2. All you do is you just divide all sides by 2. But this is important. This is a good one to know. So since the leg to the hypotenuse is 1 to 2, see 15 to 30, that means that this one is going to be 1 to square root of 3. Why did you make the hypotenuse smaller than the side? 2 is not smaller than square root of 3. Square root of 3 is like 1 point something. Yeah, you're good. Yeah, so this is really cool. So I know that z here, I don't even have to do this. And this makes sense because, oops, minimize everything. How did I minimize everything? What? How did that happen? 1 sec. Some hotkey, minimize everything. Okay. Yeah, the reason why this is cool is that on a math competition like this, you need to do things quickly. So instead of me wasting time here doing the Pythagorean theorem, like Jeff pointed out, it would be nice to just recognize, oh wait, this is a special triangle. So not only do I now know quickly what the side is here, which this side is now going to be 15 square root of 3. So this is 1/2 base times the height, which is 15 square root of 3. But also now I know the angles. I thought I was going to have to do trig to like figure out what angle this is, but I know right away that this is 60 degrees. So that means this must be 30 degrees, which is very cool because I know that the amount of area that this arc now spans is 1/12 the area of a circle, right? Because 30 degrees is 1/12 of 360. So here, this is a very cool question, Shantrix. Actually, I like this. This doesn't hurt me, right? Okay, so that's this. And then to solve for, let's say the pink part here, right? That's going to be plus pi times the radius squared, so that's 30 squared. And then it's going to be times 1/12. And the reason why I'm saying 1/12 is because it's 30 degrees out of the total 360 degrees. Yeah. Sweet. Okay, cool. All right, nice. So that's x. All right, so now let's get y. So y, let's remember, is this kind of like this gold-looking area, which let's see what that's going to be. So that's going to be this. Sorry, it's going to be this whole arc minus the triangle minus the circle. Oh, very cool. Okay. So this whole arc here, let's remember, because this is 60 degrees, that's going to be 1/6. Yeah, exactly. The arc is 60 degrees, so that's 1/6 the area of a circle. So that's 1/6 pi times 30 squared. And then we're going to subtract this, which is a quarter of a smaller... It's a quarter, right? Because this is 90 degrees. So then this is minus a quarter of pi times 15 squared. And then it's also minus this triangle again. So minus this whole thing. Okay, cool. All right. So now I need the positive difference. So I think I want to do all this minus all this, which is nice. I got a negative 1/2 minus this. That's just like a whole one. Let's see if anything like comes out. Let's see if I could do this by hand. Maybe not. Well, so y is the bigger one. So I have 1/6 minus 1/12. So that's another 1/12. Why did I add x to the equation? Where? Sorry. Shouldn't I subtract the x thing from the area of the rectangle? Oh. Yes. I should. Thank you, Raven. Sorry, yeah, this is wrong. I forgot about this. My bad. Yes, you're right. I should subtract, what is it? 15 times 30. Thank you. And then it's minus all this. Okay, cool. I was getting ahead of myself. All right, yeah, you're right, you're right. Yeah, sorry, x, this blue area, is the area of the whole rectangle, which was 15 by 30. And then it was minus this part and this part. Okay, so, okay. Are we good there so far? And then I did y is equal to 1/6. Oh, yeah, 1/6 pi 30. Where are you seeing the x from? This is the area of x, right? X is the whole rectangle minus the triangle minus the arc. That's x. Y is the whole 60-degree arc, which is this. Yeah, it's good. Minus the triangle. Sorry, minus the quarter circle, which is this. No, you're good. Keep me honest. Like, I was wrong with this. I mess up sometimes. And then minus this triangle. Okay, yeah. And now, I assume y is greater than x. So I'm going to do y minus x. Which... Now these will cancel because of... Yeah, Raven helped me out here. Because minus... Right. These will cancel. Or here, let me just write it out. It's okay. I can do it. That's why I have copy paste these days. Okay, minus, and then it's all this. right? Okay. So the first thing I'm going to notice is that... Okay, we don't need this anymore. I have my 1/2, 15, 15 root 3, being negative here, and then I have a minus here. So that makes it positive. Negative, positive goes away. So this goes away. But now, I got to put this in. I wanted to maybe like have these be nice and easy. They're not really, are they? Ugh, that's annoying. Okay, let's just, I think we just have to do this on the calculator. I was hoping something would like cancel out. Like I have a 1/6 here. Pi 30 squared. And then I have a minus. So that's plus a 12th, right? Yeah, it's not gonna make things that much easier. Let's just do the math. Okay, so 1 divided by 6. Let me put calculator up. Pi times 30 squared is that, okay, minus a quarter pi times 15 squared. Okay, cool. Okay, all right, minus 15 times 30. We gotta make sure we get all our minuses here, right? Okay, good. And then minus, so that's plus. So plus 1/12 pi times 30 squared. Should give me 2436. They said round to the nearest integer. So I think it's 2436. No, you like the calculator? It's a gold one. Is 2436 the right answer, Shantrix? Seems kind of high. Yeah, Shantrix is gonna go find it. Let me just make sure math-wise I did this right. So 1/6. Oh. No, this is wrong. I didn't multiply these things. Oh my god, that's so annoying. No, this is gonna be wrong. Ugh. Getting over being sick is the worst. I have like this brain fog that's just messing me up. Okay. 1/6 times pi times 30 squared minus 0.25 pi times 15 squared minus 15 times 30. I thought that was too high. I'm like, this is way too big of a number. Okay, good. Plus. Yeah, Shantrix. Yeah, no, I did something wrong on the calculator. Times 30 squared times pi. 80. Is the answer 80? Yes, we got it. Nice. Sick. Love that, dude. That's great. Olaf's having the best time, dude. I like little Yachty to take us out, dude. Okay, you can chill out. Okay, cool. Yeah, good question there, Shants. That's really cool, man, dude. I like that one. One second, let me move my monitor. There we go. Yeah, there was a lot of good concepts there. You know, areas of circles, areas of arcs, area of triangles, special triangles. I thought that was a very cool question. Okay, let's see. Yeah. Thanks for the solution. Yeah, this is the solution. Yeah, these are the Pascal. These are like math challenge questions. Let's see what they did real quick. Yeah, cool. Quarter circles. Yes. Yes. Oh, okay. Mm-hmm. Oh, okay, very cool. Yeah, no, yeah, different. Yeah, they didn't use special triangles. I see what they did. Yeah. Okay. They just did radii and arcs and things, which is cool. Like, that works well. It works as well. Works as well. I like the triangles. Oh, two. No, I honestly, like, Violet, I didn't really go through it either that much. But there's the link if you want to, like, take some time to look at it. I just want to make sure we have time for all the other students who have questions today. Where's Sensation today? I'm missing Sensation. Okay, let's see. Is Ayush... no, it's not on Discord. Shantrix just literally... He posted the link in Twitch. It should be if you go up a little bit. Right before you said yes and Olaf. Check the chat. No, yeah, you're okay. There's a lot going on in chat. Okay. Next up is Ayush. Ayush, are you in the Twitch chat? I think your name is Reki Rek or something, right? Where's Ayush? Yeah, Reki Rek. That's his name. Reki Rek. And then Bella needs some help with physics. And then 12th. And then Ace. Cool. Lots of good stuff today. What's up, Rek? Okay, let's do your question. All right. In an extreme adventure triathlon, participants swim 1.7 kilometers from a dock to one end of an island. Oh, okay. Run 1.5 kilometers due north along the length of the island, and then kayak back to the dock. From the dock, the angle between the lines of sight to the ends of the island measures 15 degrees. How long is the kayak leg of the race? It says, see the context too. Yeah, law of sines, law of cosines. Yeah, cool. All right. Okay, so I think we have... It's kind of weird, like, geometry-wise. Okay, I'm going to call this the dock. And then I guess there's an island. Make the island, like, circular. So this right here is, like, island. Okay. Swim 1.7 kilometers from a dock to one end of the island. Okay. I think I get this. Okay, so this is 1.7. And then 1.15 meters along the length of the island. Okay, so then they must do this. And then kayak back to the dock. It's a really pretty cello playing right now. It's just a little loud. Okay. From the dock, the angle between the lines of sight... Oh, okay. And then this is 15 degrees. Yeah, I got you. Okay. I think this is the picture. Oh, the answer. So there are two different answers? Oh, okay. Interesting. All right. They want to know this part. So let's see. I have 3 missing sides. So what I always like to do to figure out whether it's law of cosines or law of sines, count up like the things you have and you're looking for each of the quantities or the types of things. So in this case, I have 3 sides, right? 2 I know, 1 I don't. And I have 1 angle. When that happens, that's law of cosines. Oh, someone come see. What's up, Noise? How's it going, dude?
Oh, dude, I'm in the fucking pub at the minute, man. What's going on?
Oh God, we're doing law of sines, law of cosines, dude. We're doing math. What's up, dude?
Oh, law of cosines, mate. I'll fucking smash that question.
I'll fucking smash that question. Good to hear you.
I can't even see the fucking stream, man. What's going on here?
No, you gotta go see it. Go watch it, Noise.
Oh, it's loading on us. Tell you what, that MDMA, fucking lovely stuff.
Damn it. Noise, don't say that on Twitch for me, please.
Sorry. I mean alcohol.
There you go.
Oh, yeah. Right,
well, even that, I still got kids on the stream. All right. Noise is having a fun time, I guess. Yeah, no, yeah. So, no. Here's the reason. So we don't know that this angle is 90 because we don't know if we went straightly horizontal and then straight up. I think, yeah, what happened is we went a little bit up at an angle and then we went straight up. So it could be 90. It doesn't have to be. We don't know that this is 90 because we don't know if the dock to the end of the island is a straight horizontal. Yeah. Anyways, 3 sides and 1 angle is law of cosines. 2 angles and sorry, well, let me right. All right, 2 sides and 2 angles. That's gonna be law of sines. Yeah. So, yeah. You need 4 things at the end of the day. In this case, I have 3 sides. One of them is missing and 1 angle, so that's gonna be law of cosines. So let's do law of cosines. So I know from the law of cosines, this is c squared equals a squared plus b squared minus 2ab cosine of c, right? Where these are all sides, and then this is an angle, and then this angle corresponds to being the opposite of this side. So this is the angle I know, so this must be c, and then whatever, make this a, make this b. So 1.5 squared is equal to 1.7 squared plus b squared minus 2 times 1.5 times 1.7. Or actually, no, sorry, I don't know b, sorry. 1.7 times b. And then it's the cosine of 15 degrees. Right? Yeah, I can already see why this is going to have 2 answers because you have a quadratic. Yup. Okay. So, now we just gotta like simplify things. So we put 2.25 minus 1.7 squared. That's gonna be like the c part. And then this is going to, well, okay, so let's actually move that all over then, right? So really I want to move this over. Yeah, okay. So we have 0 is equal to b squared. And then this is going to be minus, let me pull the calculator. What is that going to be? What's up, math major? Doing some law of cosines right now, dog. Law of cosines. Okay, 2 times 1.7 times the cosine. Let me make sure. Good, I'm in degree mode. Okay, cool. I mean, I actually don't really like degree mode, but in this case, it's more useful. Okay, so minus ugly number. Minus 3.28 b. And then 1.7 squared minus 1.5 squared. What's up, Bella? We're going to do your questions next. I saw all yours. This is the last one right before we do it. Is that cool, Bella? Okay, and this is plus 0.64. Okay. To solve this, could use the quadratic equation. I assume you get a calculator. So I'm just going to show you how to do it with graphing. So much easier. So you can just say x squared minus 3.28x plus 0.64. Let's trace it. Let's see what comes up. Cool. Looks like there's 2 answers, right? So here, I'm going to show you. It's actually kind of cool how you can do this. This is a TI-84, which I assume is what you guys get to use in your classes and stuff. I'm a fan of it. I don't like the new Inspire. I feel like the new Inspire is like, it's too complicated. I always turn into Law of Signs. I don't know if you could turn this one into a Law of Signs. Well, yeah, you could do Law of Signs twice, and then, yeah, figure it out. Anyways, there we go. So what you want to do in this case, we want to figure out where this is equal to 0. So you can literally go here to calculate. You can say 0. Left bound, you just have to, like, say where to search, like, from the left. Just eyeball it. Yeah, you could. But there you go. So there you go. You get x is equal to 0.2 or 0.21, or let's calculate another 0 here. Actually, that's the left bound. Yeah, just eyeball it, dude. I mean, it kind of looks like 3 point something, right? Yeah, nice. Or yeah, 3.1, which I think is what you said the answers were, right? That are 3.1. So yeah, there's actually 2 different answers. I wonder why that is. I guess it depends, like, how far the dock is compared to this. Yeah. Anyways, okay, cool. So, 2 different answers. Right, the 1.5 could be coming back towards the dock. Yeah, exactly. I see. Yeah, so what Jeff is saying that, like, okay, let's say, for instance, this is actually, so this to me makes more sense being the 3.1. Right. You're very, very correct. Yeah, exactly. The other way that this could have happened, right, is that I could have had the island. Oh, fuck, I fucked up. We could have had the island be down here, I think is what could have happened, right? So this could have been 1.7. And then what? I guess this would have been the new thing. Yeah. It's just like, yeah, where the dock could be, right? And then this could be, I guess. Yeah. Yeah, 2 inches is pretty cool. Yeah, this sometimes happens also with, yeah, law of cosines specifically when you're solving for angles will get you, or no, it's law of sines, I think, right? You can get 2 different answers. Let me think. I did a TikTok video on one of these. One second, let me find it. Where did I do it? No. Yeah, here we go. It's a law of sines. So the law of sines has like an ambiguous case, which is really interesting. So I go through that in this video if anyone ever wants to watch it or something. But we go over how, like, when you're solving for the law of sines and you get an angle, you have to check if, like, the 180 minus it also works. Yeah. So yeah, check that out if you want at some point. It's pretty cool. So this is the law of cosines gives you 2 possible angles. I don't think, does the law of cosines give you 2 possible angles? It has to do with arc cosine. Arc cosine is defined within quadrants 1 and 2, right? I don't think the law of cosines usually gives you 2 answers unless you're looking for a side. Then okay. Oh, here's what I mean to say. Sorry. The law of cosines will give you 2 sides as a possible answer. The law of sines will give you 2 angles as a possible answer. And this has to do with, like, the arc sine domain, not including quadrant 2. Yeah. So this is what I talk about: 2 sides, 2 angles, and then you solve for it doing, you know, whatever domain expansion. Yeah, but our calculator will only give you 1 answer. I forget how long I made this video. But yeah, this is the weird thing, is that when you take the arc sine of this one, you get 52 degrees, which works. But you can also check whether it's the 180 minus that. Yeah. And then you have to see if the other one makes sense. Yeah. Or yeah, here in this case, Yeah. So I don't know. It's a cool. Law science is kind of tricky sometimes. Okay. Anyways, yeah. Good question there. Ayush, let's help Bella out. Bella, you're next. Here, Bella, you want to come to the stage?
Hello.
Hey. How's school going?
Sick.
You're sick?
Yeah.
Yeah, I'm sick too, honestly. My voice is like fucked up right now.
I failed my. Actually, no. I passed my stats.
That's dope.
Good job, Bella. You
But I
passed your
almost
stats
failed.
test? Okay, but you passed. The important thing is you passed. Yeah, nice. Congrats. Isn't that such a nice Christmas present you're gonna have? You know, of knowing that you passed stats.
Yeah.
Yeah. Okay. Well, let's help you out with. Is this physics coming up?
Yeah.
Cool. Let me copy it in real quick.
The concept questions, I don't know if I got them right.
Okay. Let's see. Right. Calculator. 5, 10, 12, 13, 16. Okay, let's look at 5. Okay. Well, these aren't concept questions. These are number questions, right?
The ones, I think they're at the end. I had more screenshots in.
Oh, there's more screenshots.
Oh wait, sorry. Wait, no, I didn't. Oh my gosh.
Yeah, send them if you want. Well, it's usually good to do the concept questions first and then like do the number stuff. Because the concept stuff will help the numbers make more sense. Yeah, so you can go. It's cool. Looks like we're doing normal force. Ooh.
Yeah.
Yeah, boxes on top of boxes is never fun.
I don't
Yeah.
I don't know if I'm doing that one. Is it?
Yeah, yes, number 5. You're doing number 5.
Oh.
Uh-oh.
Okay. There's something.
Nice. Got it. Okay, cool. Is this for AP Physics or pre-AP Physics?
Uh,
Or some sort of physics?
yeah.
Some sort of physics.
Yeah.
Okay. Which, all the concept questions?
Yeah. I mean,
Or which
I
ones were you
think-
like kind of unsure with?
Oops.
What's up, Hikaru?
It was 6
Okay.
and where is it? 6:50. Oh, it's not even on the one I sent you.
Okay, I'll do 6 while you're looking for it. What's up, Hikaru? What's going on, dude?
Yo.
Are you done with school? What's going on?
Yeah.
Nice, dude. What are your plans for the winter break?
Hold up.
Hold up. It says hold up.
Alright, Mom. My bad. What's up?
I said, what are your plans for the winter break? What are you doing for the winter break? Anything fun? Going anywhere?
No.
Just chilling.
I fractured a bone in my foot, so not too much.
Okay.
Yeah.
That sounds fun.
No, it doesn't.
One sec. Math major says, I'm grading finals right now. It's nice to hang out with some math folk while grading. Oh, that's dope, dude. Math major, how'd you find us? Did you just Google something on Twitch? You just Google math on Twitch? Or, I say Google, but like, that's, let us know what grade of math you're grading finals for. That's pretty cool. We have a,
Definitely.
oh, math major said they just searched math on Twitch. Awesome, yeah. Yeah, so for everyone else who's watching, we have a lot of other really fun math streamers that do streams on math on Twitch, and that's all their usernames. They're super cool.
W's in chat.
W's in the chat. Hikaru, have you taken physics yet?
No, that's next year when I'm in high
Oh.
school.
Well, here, you're going to learn some physics while I teach Bella.
Oh, nice.
W!
It was
Okay.
6:15 and then 19.
6, 15, and 19. Okay, cool. 6, 15, and 19. All right, let's look at these. And then 19. Okay, cool. If you walk along a log floating on a lake, why does the log move in the opposite direction? Oh, I know. So this is like if you're doing this
Yeah.
and there's a log and you try to walk this way, like why does the thing just like slip behind you? Just go, woo.
Yeah.
Yeah. It's because with every force, there has to be an equal and opposite force. So if you're trying to move this way, right? Your foot is like trying to apply a force to the right.
Mm-hmm.
Really in order for you to move to the right, you're really applying a force on the log that's going to the left. Okay. So in regular land where this is, for instance, the ground, okay?
Mm-hmm.
What happens is let's use different colors for things. Here, let me make, I'm going to make, what's your favorite color, Bella?
Purple.
Purple.
You did
Okay,
blue.
cool. Here, okay.
Oh, okay.
I'll be using chat.
There you go. You're purple. When you try to walk, for instance, you end up applying a force to the ground to the left. And if the ground is staying stuck and not moving, it applies an equal force on you to the right.
Right.
And that's what causes you to move forward. Okay?
Right.
That's if the ground is not moving, right? The ground is able to stay stuck, stay still. If not, right? If the ground, for instance, is now a log, which is just chilling on a bunch of water here. Now, when you apply a force on the log to move forward, the log just moves backwards to the left because
Is it like?
Mhm.
Oh well, never mind. Actually.
No, go on. What were you gonna say? Is it like what?
Well, no, because it's just like not still like the ground was. I don't know.
Uh-huh. Like the ground was able to apply kind of a normal force on you
Yeah.
that pushes you forward because it doesn't move. In this case, when you apply a force on the log, it's not stuck to anything, so it's gonna feel that force and just move backwards.
Right.
Yeah, you're not doing momentum or anything yet, right? I think this is literally just
No.
forces.
Yeah. We're doing
So-
the laws or like Newton's laws or something.
Newton's laws. Yeah. So yeah, that's kind of the thought process behind it, is that you're applying a force to the log, but the log's not stuck, so it feels this force of you and it just moves backwards.
Mm.
Whereas with the ground is stuck and the ground is able to exert a force back on you, which pushes you forward, and then it stays stuck.
Mm.
Math Manager says, I'm a college professor. I teach calculus and pre-calculus. That's very cool. Nice. I teach a lot of these things privately, I guess. If we all run to the east, we can speed up the earth. They always have this joke, right? If everyone like jumped at the same time, could we like move the orbit of the earth? And it's like, no, not really. Also, the coordination of that would just not happen. But that's kind of a weird one. Let's see. 15. According to Newton's third law, there is an XKCD. Yes, math. I'm pretty sure XKCD has done the analysis on that. Yeah. Do they still do? Is that comic still around? I remember it when I was growing up. It was cool. Each team in a tug of war pulls with equal force on the other team. What then determines which team will win?
I said neither.
Wait.
Or well,
Each team in a tug of war pulls with equal force on the other team.
but I read the question wrong. That's why. Like the amount of force.
I think
into
whoever
the
starts pulling first. The way you've learned, like F equals ma, right? Yeah,
Yeah.
right. Yeah, F mol. Yeah, good. Yeah. So if you have, for instance, they're pulling with equal force, right?
Mhm.
F1 and F2. Okay. Then the sum of the forces, which is F1 minus F2, which equals to 0, that equals the mass times acceleration, right? Sum of the forces is mass times acceleration.
Yeah.
So there should be 0 acceleration, okay? 0 acceleration, though, just means that it doesn't speed up or slow down. Like, it keeps at its same velocity. So if this thing is already moving, then it means it'll start moving at the same rate, but it won't change speeds. So if they're pulling on equal forces, I mean, you could also say that maybe the ground is different underneath them.
Right. That's what I was thinking.
Yeah, I was thinking maybe
Like,
the
you know how
ground.
in Squid Game,
Oh, in Squid Games?
or like no, in Squid Game they like they lean back into like the ground and stuff. And
Yeah. Yeah. You know what's funny? I had a friend actually who they had a Squid Game competition here in Los Angeles, like a real one.
oh.
Did you guys hear? Because it comes out. The next season comes out on what is it? The 26th,
Yeah,
right?
yeah.
Yeah. So, yeah, they did like kind of a what was it? They did a whole event where they did mock Squid Games, and yeah, it was pretty fun, like real life stuff. Yeah. One sec, let me see. Math Major says, does the problem change if one team weighs twice as much as the other? Ooh, good question. We should run to the west. Oh, you're right. Okay. Let me see.
I mean, yeah, I guess. I think my teacher
but if
was
it's-
talking about it.
Yeah, what'd they say?
But I wasn't like really understanding. He was like, he gave an example. He's like, oh, if the football team, was put in like a tug of war with the cheerleaders, who would win? And then everyone just said like the football
Oh.
team, and like vice versa.
Okay. I see, because there's more mass.
Yeah. But
Yeah,
then,
The reason to think of that has to do with the friction on the ground, which you've learned about normal forces, I guess, right?
yeah.
Okay. So, yeah, let's say we have two teams. Let's say we have the red team, and let's make it Squid Games, and whatever, the blue team and the red team. And they're pulling with equal forces, right? So the blue one, right, feels the force from the red,
Right.
and then the red one feels the force from the blue.
Right.
Okay. The other forces that are going to, for instance, prevent this thing from getting pulled in is going to be the force of friction, right?
Yeah.
Yeah. And then the same thing for this one. This would also be the force of friction. But that force of friction, right? Remember, is like mu k Fn.
Oh.
Did you know this, that the force of friction is mu k times Fn? All right, good to see you, Hikaru. Oh, you haven't seen that before?
No.
Oh, okay. So yeah, when you're calculating the force of friction between an object and the ground, okay, it's related to the normal force between the object and the ground, which the normal force is related to how heavy something is.
Right.
Yeah. This is why, again, the football team versus the cheerleaders. If you have more mass, right? So if this is like mg,
Mhm.
this means you're going to have more normal force pointing up from the ground, which means you're going to have
yeah.
more friction. Yeah.
Yeah.
So the heavier team will win because they will have more friction.
But like,
yeah.
what if the football team was like standing up straight and pulling, and then the cheerleaders were like leaning back and pulling?
Oh, okay. Okay. That gets into what's called like torque at this point, because you're saying what's the advantage of, for instance, getting your center of mass like really low, right, and pulling this way, versus like being up top here and like pulling.
Yeah.
Yeah, that has to do with torque, which I don't think you're really going to cover in this part yet. In that, if you think of this as like a pivot point for the person, if the force is applying further up, it makes it easier to pull that person over. Versus if someone's like low to the ground, now there's not as much torque to like flip them forward. Yeah.
Okay.
Right. Yeah. Leaning back can maximize the force application without slipping. Right. Yeah.
Okay.
So I think the main answer, and I copy pasted this in the ChatGPT just to see what they think. Yeah, they agree that it's the friction. They say the friction is the main thing that's gonna determine which team wins.
Nice. Okay.
Yeah. Okay. Cool. All right. So that's 15. All right, and then what do we got? 19.
Yeah.
A heavy crate race on the bed of a flatbed truck. When the truck accelerates, the crate remains where it is on the truck, so it accelerates. Yeah, I love this. This is such a good question. Ha 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 ha. I love this one. Okay. So we have truck, right?
Mm-hmm.
Truck needs the same wheels. And then you have a box, which I'm going to put a different color for the box. A box like this, okay? And I like to always think about, like, what are the forces on this box, right? So the box is definitely going to have the force of gravity pulling down.
Yeah.
And then it's also going to have the normal force pointing up. All right. Now, if the entire truck here, right, starts accelerating to the right, okay. Let's move over a little bit.
Hello.
What's up, Ethan? How's it going, dude?
Yeah, I have the greatest news.
You have the greatest news? What's up, dude? Tell us the greatest news. What's going on, dog?
So, you remember like last week when I was saying I had a physics exam?
Yeah.
Exam
Yeah.
I already know one of the two.
Okay, nice. How'd you do? Let us know.
I got my, well, I didn't get the physics paper since I can't keep it, but
Okay.
I saw my grade.
What's your grade?
I got a literal 94.5.
Oh, fuck yeah, dude. Nice. Good job, Ethan.
Yep, I'm proud of myself.
I'm proud of you, too.
I'm just wondering now if that will
Yes.
give me to an A.
Someone in the chat said, congrats to you, Ethan, dude. Math major said, congrats to you.
Yeah, thanks.
Yeah, you're good, dude. Nice.
But yes, I'm just trying to figure out if that will get me to an A. Like,
Well-
I mean, if there is some formula that I can use to see if it'll get me to an A.
There is.
What am I trying-
Yeah,
Is it- what
exactly.
is it?
Yeah, Bella's right. It depends on the grade distribution. Depends on, like, what percentage your exams versus homework and whatever that stuff is.
I think it contributes to like 35% of the grade.
Okay. Well, actually, here's a good question. Do you know what was your grade before the exam?
Yes, I do. I remember exactly.
Yeah, what was your grade before the exam?
It was
I can do it. So it's a quick math thing.
okay. So 86.56. That's the exam grade. Not the exam grade, but the grade before the exam.
That's your grade in the class before the exam. Okay.
Mhm.
And then you got a 94 on your final.
94.5 then.
Okay, fine. And it's worth 35% of your grade?
Hold on. Let me think. I think it is 35. If not, then it's 30.
Okay, let's just say
One of those
30%.
two.
Okay. So here's what's gonna happen. So before you took the final, the all of your grade was basically this. After you've taken the final, now only 70% of this determines your grade, and the other 30% gets determined by this.
Alright.
So if I can do 0.7 times 86.56 plus 0.3 times 94.5, that'll tell me what your new grade is.
Really?
Yep. I mean, I'm making a couple assumptions here, but
Couple of assumptions. Alright.
let's just see. So it's that plus 0.3 times 94.5. That'll get you an 88.9.
Dang. Alright.
So very
cool.
close to an A. Very close to an A. It's an 89. But sometimes teachers will just bump you a point, just be like, whatever.
Maybe. I don't know.
My teachers hate me, so they don't.
Your
care.
teachers hate you, Bella? Uh-oh.
No, I'm just kidding. But they're not that generous.
They're not that generous, so like they're not gonna give you a whole point.
My stats teacher is so lazy.
Yeah? Why's you so lazy? What do you do?
She decided to, like, I mean, I think a lot of teachers do this, but like she reuses all her tests like every year
Yes.
until she found out last year that they cheated.
That's the same thing I got. That's the same thing I had there.
Yeah.
The
Well,
exam.
yeah. Because it takes a lot of effort for teachers to create new tests, but then they don't realize that, it's just, especially, this is why they don't give the test back half the time.
But then she realized that they were like taking the test from last year and stuff.
Sure.
So then
Yep.
she used like mathematic tests, and like kids are still cheating because like they make an account and stuff. But she's like, oh, it's so expensive and stuff. Yeah.
I always say that, like, I don't know, like, you kids are crafty. You'll always find a way. You'll always find a way to and it's just so funny because if that it's cool, it's smart, it's optimization. You're trying to like optimize like what's the easiest way to like get through this, and that is useful for other situations in life where we're trying to make things easier and simpler. But the whole point of like classes and tests is they're supposed to be hard because you're supposed to like learn enough things to do that, I get it. It's just, I think if people took all that effort they took into cheating into just actually doing the test, they would be off much better. Like I praise the ingenuity. It's cool. Like you guys figured some stuff out, but it's not the point. It's like if you were lifting weights at the gym and you're like, oh, I want to be able to lift the heaviest weights, so I found this way to like basically cheat on the machine so it doesn't feel as heavy. But that's not the point of going to the gym.
Yeah.
It's not to just like, oh, I can fake lift heavy weights. It's because like I need to get stronger. Anyways, yeah, I know. It's why I would dread being a teacher these days with all the ChatGPT, all the whatever, because it must be so difficult to try to build bulletproof things that can't just be like, again, just shortcut.
My lit teacher,
Mhm.
I think she's like, she had a story for us to read and like answers like for a spotlight, so like whatever. And some kids use ChatGPT, and I think the answer from ChatGPT, I don't think it was like, I think she said it wasn't like the right story or something.
Oh, it was just hallucinating.
Yeah.
Oh my god.
So she's like,
I have the post up too. Or like she has the post on Classroom saying that
Like, is she publicly shaming this person?
yeah, she probably should. Like,
Yeah, Math Major says, having to catch cheaters is the worst part of my job. I had to report a bunch of students for ChatGPT this semester. Yeah, I know.
I just saw it. She did in the beginning of the school year too.
Yeah, well, it's because, I mean...
Oh, she said, FYI, the settings spotlight. Oh, wait. No, that's a different one.
Yeah. They also have things that can automatically detect how much is written by AI these days.
Oh, yeah, see? Moreover, homework assignments like last night's require detailed thoughtful analysis with textual support from the actual story you were assigned.
Like, you need to read the actual book.
Yeah.
The T. Yeah. It's a two-pronged change. What's up, Ethan?
Okay, I'm proud of myself for that.
Oh, I'm proud of you, dude. We're all proud of you. Good job. You'll probably get an A. Just tell the teacher to bump you up a point. You'll be fine.
Alright then.
Yeah.
I gotta go then.
Alright, good to see you, Ethan. Alright, let me help out Bella with the rest of this. And then we can talk more about ChatGPT. Okay. So Bella, we have the box, right, in the back of the truck.
Mm-hmm.
And the box is feeling and so since the car is accelerating to the right, okay, that means everything attached to the car needs to also be accelerating to the right.
Right.
Okay. So if I look at the box here, the forces on the box so far is the force of gravity pulling it down, the normal force pointing it up, but I need to have some sort of force to the right which keeps it also accelerating. Do you know what that force is going to be?
No.
It's friction.
Oh.
It's friction is what it is, yeah. So this yeah, go on.
I thought it would have been like at the same time I didn't know because like it wasn't the truck, but like I thought it would be something with the truck.
It
and
is.
then afterwards the friction would be like stopping it or something.
Yeah, no. It's the friction of the crate and the truck, between the crate and the truck.
Oh.
It's weird because, you know, you're like, whoa. Friction is moving this thing forward. I thought friction only just opposes motion and stuff. The way I like to think about this is friction always opposes where something wants to go. Okay? So let's imagine like this was like super slippery, like it was an ice block or something. If the truck moves forward to the right, the box wants to just stay still in like the frame of the earth and stuff. So friction opposes where it wants to go. So it wants to stay still. So friction opposes that to keep it moving keep it moving to the right.
Okay.
Yeah. The other similar question that comes up all the time is this. The inclined plane, right?
Mm.
Have you done inclined planes yet? Maybe not.
No.
Okay. Well, anyways, you'll get to this. So if you have like a box on an inclined plane, right? And this thing is just sitting around, right? Which direction does this want to move?
Down?
Good. Right. It wants to move down, okay? And so what would happen is if it wants to move down, friction would oppose it up to the left or to the top. Yeah, up. Yeah, okay. Now, if for instance instead I was like sliding this thing up the ramp, okay?
Yeah.
Now friction would point down because it's opposing the motion of where it's trying to go. Yeah. So
is that like when it's in motion or like when the plane's
good.
Like
oh yeah, and there's I know what you're also talking about. There's also when they have what is it? They have they have this whole thing like moving to the left and to the right.
Oh.
Yeah, that changes stuff as well. But usually it's like you're throwing a box up the plane, or you're just letting it like slide down the plane, and friction will point in two different directions depending on where it's going.
Okay.
Yeah. Okay. So yeah, that one is friction. Cool.
Yeah.
All right. So then what was the next one we had? It was these, right?
Yeah.
Okay. Y'all keep talking to Nightbot. They talking to Nightbot in the chat. More than half of them fessed up to it in a meeting. It was really great to connect with students and talk to them about it. But at the same time, it was really hard to have those conversations. Yeah. I also say, math major, unless someone is told what they're doing is wrong, they're just going to keep doing it. So I know a lot of teachers don't want to have to report cheating and stuff because there's a lot of paperwork involved with it. And then you want to give people the benefit of the doubt, right? I don't want to be like, oh, you must be cheating. And they're like, no, I actually did this. And you're like, But sometimes it's blatant. Like I know you didn't write that. I know 100% you didn't write that. Oh, that's smart. Okay. Yeah. What were you going to say, Bella?
My lit teacher, she has like this extension to find out if people copy and pasted.
Ooh, yeah. Basically seeing how fast they type.
Yeah.
Yeah, that's a smart one. Yeah,
I think instant replay too.
Oh my god. I think Khan Academy has this too with their new Khanmigo app or whatnot. I saw it on like 60 minutes or something, but it's like a dashboard where the teachers can see like so and so copy and pasted from an anonymous source, like 60 fucking words, and you're like, okay, that's cheating. Wow, math majors, you reported almost a quarter of your students this semester.
Oh,
that's nuts. Oh, but if they fess up and self-report, they get a lighter punishment. Good. I'm glad there's at least like a positive path towards rehab. Yeah. Okay, let's see. Question 5 here, right?
Yeah.
A 20 kilogram block rests on a table. What is the weight of the box and the normal force acting on it? Okay.
Like.
And just from the 20 kilogram box, like before we have the 10 kilogram box on it, right? I kind of assume that's what's happening.
Yeah.
Also, what does your teacher use for G? Do they use 9.8, 9.81, or 10?
Yeah, 9.8.
Okay, cool. If they use 10, I start judging teachers when they do that. Okay. So force of gravity.
People too.
Yeah, you judge people pretty hard for that. This is just going to be this is M times G, which is going to be 196 newtons.
So would it just be the same?
Yes, they would be the same. But then you place the 10 kilogram box on top of it. Okay, now things get weird. Determine the normal force that the table exerts on the 20 kilogram box. Okay, so now this is different, right? So the 10 kilogram box, right, is going to have a force downwards of 98. Okay, and then it's going to have some normal force acting on it as well, right?
Yeah.
Bum, bum.
Well, wouldn't it be the the 196 going up as well, or no? Because it cancels out.
Yeah, so bum. You can treat it as like determine the normal force that the table exerts on the 20 kilogram box and the normal force that the 20 kilogram box exerts on the 10. Well, this is going to be 98, right? This is still going to feel 98.
Yeah.
But now this box feels the 196 plus 98.
Yeah.
So the force of gravity never changes. That's always just m times g. I don't care what's on top of whatever, right?
Yeah.
So this is FG of the green box. The difference here is that, so now, since this, and sometimes I like to do this, let's do this. Let's say 1 and then 2, okay? I'm going to say that F1 on 2 is equal to 98. So the force from block 1 onto block 2 is 98. But that means the force from block 2 onto block 1 must also be 98.
Right.
This is a body diagram for free. Yes. It's a free body diagram. Yeah. So this right here is what I would say is like F21, okay? And the only thing that can provide that, right, is going to be the normal force that's acting on this box down here. Yeah. It's kind of a tricky one, honestly, this stuff, because some people want to like add this to this and whatnot. I'm like, no. Think about each thing independently.
Right.
In terms of forces of gravity, and then set the normal force to what they need to be such that the accelerations of things make sense. Both of these things need to have a net force of 0 on them because they're not moving.
Okay. Yeah.
So if this has 98 pulling down, it needs to have 98 pulling up. I don't care, right?
Wait, so whenever an object is still, it just has a net force of 0?
Good. Yes. Yeah, whenever an object is still, net force is 0. Yes.
Okay.
Because sum of forces is 0. So if we look at this block, okay, now that the 10 kilograms is on top of it, it has a couple forces. So it has the force of gravity, okay, but now it also has the force of block 1 acting on it. So it had this 98 is also another thing. So the normal force has to combat both of these things. And that's why it's 196 plus 98.
Okay.
Yeah?
Yeah.
Okay. What was the next one? 10, 12, 13. Okay, let's go through it. Am I going to be playing Roblox on Saturday? I could. I haven't played Roblox in forever. We used to do, what was that game called? We used to play all the time. Epic Mini Games or something?
Oh my gosh, that game is so fun.
Oh, is it? Oh, maybe we'll do it this weekend. Are you around this weekend, Bella? You're done with exams probably this week, yeah? Oh, maybe I'll make it next week.
I have midterms like next week.
No,
like
next week
right
is
after
Christmas.
break.
Oh,
Well,
after
right
break.
after
Okay.
break, yeah.
Okay.
It's like
Okay.
midterms week right after break, which is kind
That's
of
so rude.
annoying. Yeah.
I know teachers that would do that. Yeah, they would do finals after Christmas. I think that's incredibly cruel. Like, what? Why would you do that? Like, don't do it.
No, God!
All right. How much tension must a rope withstand if it is used to accelerate a 1,200 kilogram car vertically upwards at 0.8 meters per second squared? Okay. So let's draw this. This is called free body diagrams. So we have this thing, right, which is 1,200 kilograms.
Mm-hmm.
What are the forces acting on it?
Gravity.
Gravity. Good. Nice. So you got FG pulling down, which is going to be 1,200 times 9.8. And then what's the other force acting on it?
Wait,
said
where's the rope?
Good.
Like,
yeah,
I'm
where's the rope?
confused about-
The rope is up here. The rope is like this.
So like it's holding onto it.
It's at the top, right? And it's
Yeah.
it's pulling it up. Yeah.
Oh, it's pulling it up.
Yeah, they said vertically, right?
Oh, okay.
It's kind of weird, but yes, they're pulling it up.
Like the force of the pull, I guess.
Good. Yeah. This is gonna be the force of the tension.
Oh.
All right. So again, once you have your forces written out, then this is where we write out Newton's law, which is F equals ma.
Okay.
And so I'm gonna add up the forces. So I have Ft pulling up, and then I'm gonna say minus Fg because that's pulling down.
Alright.
And then this must be equal to the mass of this thing times the acceleration. Now, what is the acceleration of this object? What did it say?
0.8 meters per
0.8.
second squared.
Mm-hmm. And is that positive or negative?
Positive.
Positive because it's upwards. Yeah. When you do these types of questions, just always designate which direction is positive, which one's negative, and as long as you're consistent when labeling your forces and labeling your accelerations, you'll be okay.
Okay.
So yes, up is usually positive, and down is usually negative. This will get weird sometimes when we have like pulleys and stuff, though.
Oh, I think we're doing that a lab this week.
Yeah, you're probably doing that next. Yeah. So that's why, for instance, force of gravity here, I put it as negative because it's pointing down. And then tension, I kept positive because it's pointing up. Right. So you get Ft minus 1200 times 9.8 has to equal the mass 1200 times the acceleration, which is 0.8. And so now you can just solve for the tension.
Okay.
Yeah. I know some people would be tempted to just multiply like these two things by each other. You're like, oh cool, I have a mass and an acceleration.
Yeah.
You're like, oh look, 1200 times 0.8, like must be right? It's like, no. You have to draw the diagram. The reason why it's not just this is that gravity is also fighting you, pulling it down.
All right.
So
Okay.
the force of tension is the 1200 times 0.8, but it's also plus the force of gravity, which is 1200 times 9.8.
Wait, so you're subtracting that because it's going down?
Good, but when I
opposed to the
solve,
tension?
but when I solve for the tension, you see how I'm going to add that to both sides?
Right. Yeah.
Yeah.
But like how you put it in the equation is based on like the signs. Or,
Good.
like-
It's based on the direction. Yeah.
Yeah.
Yeah. Just intuitively, like, if you're trying to think of it in, I don't know, real world physics terms, you could think that, okay, the force, if I wasn't fighting gravity, would just be the mass times the acceleration, which would just be the 1200 times the 0.8.
Right.
But because the rope needs to also fight the force of gravity pulling it down, that's why you add the 1200 times 9.8, because that's the force of gravity that's also fighting it.
Mm.
And you could, without a calculator, could you? But math major, I don't know how to do 10.6 times 1200. I guess I kind of do. That's like 10 times 1200, 0.6, 72. Yeah, you could do it. You could do it without a calculator, yeah.
Oh my gosh, one of the kids in my school, or my friends, they got into Cornell and Princeton.
Oh, nice. Congrats. They should go to Princeton. Cornell is very depressing.
Well, it's two different friends. One of them, one friend.
Oh,
got
one of them's
into
going to
Cornell.
Cornell and one of them's going to Princeton. Okay.
Yeah, the
Check
one
up on your Cornell friend.
Yeah, no, literally, he's like, yeah, my dad doesn't care about me. And like his dad like calls him like stupid.
Wow.
Like he's like, yeah, when you get there, you're gonna be the bottom, like the low bottom.
Well, this is not how we teach our children.
Your knowledge is 10% of mine.
Yeah, there's some interesting parenting styles out there. I guess sometimes they say, right, like steel sharpens steel, or like the hottest fires make the strongest steel. But this tends to like push kids too much, and then they just start breaking. You know?
Yeah.
I don't know. There's a balance.
But he's like an I don't know. Like he gets hundreds on every single test possible.
Okay.
But like
well, I mean,
lately,
something's working.
lately he's been struggling in physics, and his dad like yelled at him.
Oh god.
Like I feel bad.
Oh no.
Because I don't think he's ever done bad before.
Yeah, I say there's always a point. There's always gonna be some class that you hit where you hit like what I call like the proverbial wall, and you don't understand what's going on, and it's a real ego. It's an ego blow. Were you saying it's every class for you? What'd you say?
No, mine was chem.
Yours was chem. Okay.
And then after that, I just stopped trying to learn anything.
No. Don't let me stop. Yeah. So mine was quantum mechanics when I got into grad school. I ended up failing it. Yeah. Because, and it was weird because throughout my life, I always was able to understand everything at some point. I just had to sit down and study it, and I would get it eventually. But for whatever reason, and it's mainly because I didn't have a really strong linear algebra background, which you really need for quantum mechanics. And I just hit this point where I'm like, am I retarded? Like, why can I not get this? I don't understand this. And just no matter how much I tried, I felt dumb. So it's okay.
That's
we all get
my stats class right now.
That's you in stats? Yeah. No, it's okay. We all get humbled at some point. Yeah, it happens.
Yeah. And the Cornell guy, he sits at my table in stats, and like I just feel bad.
AG says mine was fluid mechanics. Now I specialize in fluid analysis. You can make it through. Exactly. Yes. Yeah, I did miserable at quantum mechanics, but after like tutoring it years later, it makes a lot more sense to me now. How did I manage to pass it? I didn't. So in grad school, a B- is failing, which is really annoying. So I technically got put on academic probation. It sucked. But I managed to pass the comp exam at the end of the year. So I learned enough quantum mechanics to find. Also, that class was pretty fucked because the final was 90% of your grade. Like the whole class structure was 10% homework, 90% final exam.
Oh.
Yeah, right? So, yeah, it was kind of one of these where I was just like, whatever, dog. Like, I'll sort it out later. Yes, and Math Major says, I can second this as another person with a PhD. Very cool, Math. What's your PhD in, Math Major? I assume it's in math. Everyone eventually hits that wall. Yeah, you all hit the wall eventually. We're all human.
I want to hit myself into it.
You want to hit yourself into the wall? Oh, Math Majors is in math. That's cool, man. Math PhD. I'm a physics PhD. He's a math PhD. That's cool. Nice. Okay. A 12 kilogram bucket is lowered vertically by a rope in which there's 163 newtons of tension. Okay, so this is the tension pointing up, right? And then we're going to have the force of gravity pulling down.
Wait, let me read the question again.
Yeah, read the question real quick. I'm just going to draw it out for you.
Okay.
So, in the last case, we were finding the tension based on the acceleration, right?
Yeah.
Wherever we did it.
Bro, I think we were just finding the
No, it was here, right? Yeah. So here we found the tension based on the acceleration and the force of gravity.
Oh.
Here we're finding the acceleration based on the tension and the force of gravity.
Okay.
You either have both the forces and you're finding acceleration, or you have one of the forces and acceleration and you're finding the other force.
Okay.
That's what switched. So again, positive, minus, and so that's going to be 163 minus 12 times 9.8. Okay. So let's do that. 163 minus 12 times 9.8. And that's going to end up equaling 45.4. Oh, so actually kind of nice. Sure. All right, so the acceleration is up, technically, okay?
Wait, that's the acceleration?
Yeah.
Why is it so high?
Oh, wait.
Is
Sorry.
that high?
Divided by the mass. Divided by the mass. I fucked up.
No.
Sorry. This is equal to MA, right? So we still got to divide by mass. Yes. Thank you, Rick. Yeah. Sorry. Divide by mass. So divide that by 12. That is high. Okay. Now it's better. 3.78. Okay. It's positive though. Isn't that kind of weird that the acceleration is positive even though this thing is moving down? Yeah. So the way to think about this is this thing is slowing down as it moves down. Okay?
Okay.
So positive acceleration means that velocity is going more positive. Okay?
Right.
So if this thing was moving down at, let's say, like negative 30 meters per second, now it's going to be going down at like negative 15 meters per second. So it's still moving down, but it's like slowing down as it goes down.
Okay.
Yeah. Let me see. Shouldn't it be negative then? FG minus FT. Yeah. So Rec, it depends on how we're defining the directions. Okay. So I'm defining up as positive and down as negative. Okay. So that's why, for instance, force of gravity was negative and the force of tension was positive. Yeah. So my acceleration being positive means in this direction. You are right that usually if I know something's moving down, I'll end up calling this the positive direction and I'll call this the negative direction. But that would switch the signs of these. Yeah, okay. Yeah, you just got to be consistent. Just call something positive, call something negative. Yeah. Yeah, good to see you, Raven Violet. Yeah, make sure to follow us. And also, here's a calendar if anyone wants to ever see like the other math streamers when they're streaming. This is everyone on the schedule. So, I guess no one's streaming later today, but Zach's a math. Zach just got his PhD in math like last week. That's E to the 2i pi. He's streaming tomorrow. Yes, there he is. Yeah, shout out to Zach. Yeah, Zach's fucking great. Yeah. We got a couple math PhDs in the house. But yeah, Zach just got his. So make sure to follow him because he'll be streaming tomorrow. And then we have another friend of ours, Penn Center. He's I want to say a math professor as well for some college in Canada. So he does math help as well. Apparently, yeah, you've been summoned, dude. As my mother would say, like, the ears start tingling, and she's like, someone was talking about me. Yeah, apparently. Okay, let's see. What's next? 12, and then... Fuck, where are the other ones? 13, 16. Okay, let's roll through them. Not these. These. A says yes, leave soon. Yeah, here, let me do 13 for Bella, then I'll do your question. And then... and then, yeah, Bella, send me a screenshot for 16. I'll do it later, and I'll send it over to you after the stream. Is that cool?
Okay.
Cool. All right, an elevator of mass is designed to be maximum acceleration. Is this... Okay, cool. All right. Here's the elevator. And it's always going to have... this is 4850. Is the mass. So the force of gravity pulling down is going to be 4850 times 9.8. Okay. And then they say the maximum acceleration is supposed to be 0.0680. A equals 0.0680 G. Okay. What are and then like what are the tension forces here? No, G is gravity. Yeah, not grams. This is gravity units. Okay. So in reality, the force of gravity here is 4850 G. Yeah, it's kind of what they're saying. So we could, yeah, whatever. I'm gonna leave it. This should be times 9.8. Okay, there are two situations here, Bella. So the maximum acceleration is technically plus or minus this. So I want the case of where it's falling down with this acceleration, and also the case of where it's being pulled up with this acceleration. There are two different answers. Yeah, exactly. So here's what you're going to do. You're going to say FT minus 4850 G is equal to positive 0.0680 G. And then also you're going to have FT minus 4850 G is equal to negative 0.0680 G. Okay? Because they're two different types of accelerations. It can either be like falling down and I'm slowing it down, or it can be going up and I'm pulling it up. In both cases, it's accelerating at a certain amount, but they're different tensions. Okay. And then we have to multiply this by the mass. Sorry. I keep forgetting the mass today. Jesus.
Wait, I thought you. Oh.
Right, because it's F equals ma. So sorry, I was writing the accelerations, but I was forgetting the mass term.
Wait, so why do you subtract the tension from the
Okay.
weight, the
So
mass?
yeah. So the force of gravity is. They're really messing me with this G. I don't like this G. This is like 4850 G, is what we say. G is the 9.8. Okay.
Yeah.
He's like, yeah. You know,
wait,
fuck this.
so
Here, I'm gonna get rid of this G thing. I just don't like this G. The G is confusing. Okay. Instead of I'm just gonna write this as it should be, which is 1 second. Let me do it.
times the 9.8.
Yes, I'm just gonna get it, just because it just makes it unnecessarily complicated. Okay. A is 0.664. Oh, 0.6664. And that's gonna be plus or minus. Force of gravity is this 4850 times 9.8. So that's going to equal to 47530. And that's in newtons, okay. And then in both cases, right, tension is pulling up, gravity's pulling down. That's why we do Ft minus the force of gravity in both cases. But in one case, it's m times positive 0.6664. And in the other case, it's m times negative 0.6664. Okay? It's two different cases. One of them is it's the acceleration is positive, so this thing is like either slowing down and going up or something, and the other case it's like going down. Okay. So M here is now 4850. This is 4850. This I know is this number. And so we're just going to add it into this one, and then we're also going to add it to this one, but this one's going to be negative. Okay. So let's do, what was it? 4850 times this. So that's 3232.04. And then this is negative 32.04. So then if I add FG to this one, we're going to get two cases. So let's see. Who is this number, right? So this number plus this. It's going to get me, wow, big number. 50762.04. And then if we add it to the negative 32, it's really just like subtracting.
Oh, you just add, okay.
I'm just adding it to the positive one. I'm adding it to the negative one.
Right.
So this gets me another case, 44,297.96 newtons. Okay. So this is the minimum. This is the maximum. Okay.
Right.
The minimum force is like the tension so that it falls down, but it's not falling down too quick. This is like falling down. And then the positive one is trying to pull it up. So, yeah, those are the two cases.
I see. Okay.
Cool. Makes sense? Yeah?
Yeah.
Nice. Okay. Let me do Ace. I'll do your question because then I gotta go teach another student in 5 minutes. But Bella, I hope that helps you out with your final. Send me question 16 later, the screenshot for that one, and then I'll write up a quick solution for it and get it to you as well. Or did you already give it to me? Is that the? No, that was a conceptual one. What is it?
I don't know. I'll just screenshot it right now.
Okay, cool. All right, nice. Good job, Bella. I hope you feel better too. I empathize with feeling sick. It fucking sucks.
Yeah.
My brain's been like kind of mush today, but you guys are helping me out.
I have a quiz on this one, and he wants us to memorize the laws too. So I have to.
Lots of flashcards. Or I guess
mean,
Quizlet.
well,
Y'all use Quizlet these days, right?
It's just the 3, and then I have to do the problems for the second law or whatever.
Oh, okay. Not too bad. Ace, what's up? I got 5 minutes. Let me do your last. Thanks for waiting around, Ace. By the way, sorry, it's been a busy day today. Hi, is there any way you can do tomorrow? These kids trying to cancel tutoring me like an hour before I'm supposed to teach. Man, god damn it. Kids.
Oh, they canceled?
Well, they're like, can we do it tomorrow? And I'm like, well, I scheduled you for today. Okay, here we go. Yeah, no problem. All right, here we go. For each current carrying conductor, sketch a view of the magnetic field based on the direction of the current flow. Here. Okay, I assume they're talking about something like this. So we have... I don't know. Well, yeah, you're very welcome, though. You're so welcome. Okay. If we have current going in this direction, okay, what we end up using is called like the right-hand rule, which is the thumb points in the direction of the current, and curling your fingers around points in the direction of the magnetic field. For the math major people here, this is called the curl, which is, I believe it's like this. Yeah, it's like, this is kind of what it is. This is the technical math definition of it. But that means if you have current, here, let's make the current green, for instance. Current green pulling this way. And like I point my thumb down that, then wrapping my fingers around will point a B field in this direction. Does that make sense? It's kind of a cool thing. Nabla. Yeah, Nabla cross I. Yeah, exactly, dude. Yep, okay, cool. All right, now they do this. So this means that the current is coming out of the page. So we have two different ways we can write, because we're trying to express 3D things in 2D paper. So the way to do that is something like this, and then something like this. This means out, this means in. The way I like to remember this is, say you had like an arrow that you were shooting. If you shot the arrow into the page, you would see the fins or the feather parts on the end. That's how to remember that like X is going in. And then if the arrow is coming out of the page and it was going to hit you, you would be seeing the pointy end of the arrow versus the tail. That's how I remember it. So this is coming out of the page. So if you take your thumb, right, and point it out of the page coming towards you, which I guess to you guys is that way. The camera's backwards. That means it's going to curve around to the left. So in this case, this is I, and then B is going to curve around this way. And then same thing for here, right? Current's going this way. Thumb, magnetic field is going to curl around this way. This one going into the page. Current's going to go around this way. Or so magnetic field's going to go around this way. And then this one's kind of cool. Okay, so here you have your thumb, right? Or let's put the red part of my thumb. The red part of your thumb is pointing this way. And then your hand, right, is like curling around like this. So what this does is this creates a magnetic field that's like curling like this around, which we say is going into the page on this side, which we would write like this. But then on this side, it's coming out of the page. See how this is like coming around and coming out? So this ends up being like this. Yeah, Ace, does this make sense to you? Ace is also he's also in the Discord. Yeah, makes sense. Yeah, this is cool stuff. It's very useful to know. But yeah, you'll get used to like drawing these things and like this is kind of weird they did it this way. Usually we just draw things either going like I don't know, like into the page, out of the page, and not like this like pseudo diagonal. Yeah. Okay, cool. All right, nice. Weird. Yeah, it is weird. Yeah, it's weird for them to draw it like this. Usually I would just draw a wire doing this or a wire doing this, or I would say it's into the page or out of the page. Yeah. Anyways, nice. Good job, Ace. That's good. Okay. I gotta run. I gotta go teach another student. But good job, Ace.
Well done! Well done!
Yes. Sweet. Okay, so with that, let's close out the stream. All right, thank you everyone for coming to office hours today. Appreciate all the new people we had. Raven Violet and Math Major 7. Yeah, thanks for coming. Stop by, guys. Yeah, please make sure to go follow all of our awesome math streamer friends. There they are. And then if you want to see when they're streaming, we have a calendar up. Yeah. So go learn, have fun. Our next stream will be tomorrow. That's going to be an hour later. That'll be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Also, be on the look in the server. I'm going to announce we have a AMA podcast guest this Friday. It's a college admissions guru. He's like people pay this guy a ton of fucking money to like get people into college, and he's going to come onto our stream for free and answer all your questions on how to like get into college and what to do. He's a really cool guy. I love him. His name's Perry. We'll make an announcement in the Discord. So, yeah. Submit your questions for him to answer, and we'll do them. All right. Let me see. Let's go raid somebody. Who are we going to go raid today? Streamer manager. Amaze. Yeah. Yes. And I'll get all your channel points and stuff. Okay. Who are we going to go raid? Who am I following? Monday's always a weird day. No one really streams on Monday. Oh, I love this. Here we go. What do we do? Charity event for the Fred Hutch Cancer Center. Or, oh, math semester study exam. Let's do this. Let's go say hi to Math Happens. Yeah, this looks cool. This guy's teaching math. If you guys want to go learn about math, I think this guy's doing a final exam review. Cool. All right. We will see you guys tomorrow. Have a wonderful rest of your Monday. Good luck with all your tests if you have them tomorrow. And we will see you tomorrow. Peace.